So what is it, it's for 22, I think, correction, cover no insurance.
Oh,
It's
right.
for the class, right, well, no, like, insurance.
It's, it does this year, but you have to.
They're usually like, oh, no, insurance, we, here's as well.
Yeah.
Right, yeah. I mean,
Okay, let's get quiet. Was there any questions on the project?
Yeah.
That's good.
How many pages are these slides?
It's up to you, but you need at least 3 for each category, but it seems to be around 5 to 7 is usually.
I have 2 questions. What are we supposed to write for the 3 things we learned from the graph? Because I can only find one thing that I learned.
are we just supposed to like explain it?
Yeah, it could just be anything. More people go out than I thought would.
Oh, okay. And then the second thing is, which one do we need the trend line and the R squared for?
The third one, the scatter plot.
The scatter, okay.
Yeah, the scatter plot, you need the trend line and R squared because that's the one with the points and the line goes through it. And so that would be the third one. Cause you have 2 numerical pieces of data.
Okay, so what data does that go with? The quantitative or the qualitative?
Quantitative,
Okay,
the 2 numerical values that are together.
okay, so we're only doing like one of them? Like, for mine, it was like how many times the community eats out. Am I only using those numbers or do I use like how much they would spend on a meal?
How much they would spend on a meal you could use on the second group, where you have to do the histogram. And then
Cause I was planning on using the how many times they eat out for the histogram. And then the third one was gonna be how much they would spend.
okay, the third one has to be 2 pairs of data that go together. And for how many times they eat out, you have a range right now. You maybe take the middle then, because it has to be a numerical value. You can't add 2 to 5 up.
Okay,
I thought that was your qualitative.
so I call it.
Qualitative is the food place.
Yeah.
Yeah, since that's a range of values, maybe take the middle, like 1 to 4, make it 3 or 2.
For the histogram.
Yeah.
Okay. So like,
So like if there was 9 of them that ate 1 to 4 times in a week, then we're gonna be at 5 times.
yeah, I changed it to 4 to 8 times a month and then 12 to 16 times a month.
So maybe go with 6 times. Like pick the number in the middle. But you can't have a range of that. So on average, it's probably about 6.
So I mean, still 8. Yeah, because the second part was the histogram, you have to have the mean, median, and modes, right? And then what I would graph down here like the range of it.
The histogram.
Yeah.
For the history, so
Yeah, what are
you how many people do you have to report it?
It's 4 to 8 and 17.
Yeah. So you're gonna have 17 6.
Honestly, it looks up from these.
In order to find mean, median, most range, all of those, you have to have all your data.
Yeah.
out.
Because if I was doing mine.
So like between 4 to 8, like you said, it's 12 to 16, but 14.
Ask her. I think-
1 to 2, so like 1 to 2, 3 to 4. What would I do?
2.
So then I would just enter the 6, the 14, the 2, and the 3.
Yeah, so that's how long my mean time will work.
Like,
Oh, we have to do every single one, all 25.
Because remember we have
That's why I'm highlighting, it's like all of them. So, yeah.
I'm finished.
So.
25.
Because me and somebody else, we put a.
But.
And the actual projects we do on one.
Okay, because I remember the pie chart, the bar graph,
for the first.
I haven't already on Alex because that's what.
So.
Yes.
Yeah.
I mean, you gotta realize Alex is one that even has.
So that's all I'm asking, like the 6, blah, 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 14, this happened this many times, 2 this many times, 3 this many times.
Oh,
For the, just for the graph of the history.
I know it was.
The histogram, mean, median, mode, and range.
Okay, oh, all right, that makes sense.
Yeah. Oh, wait, what is that? It's like, no, it's like, the top when you get up to like. It was so. Yeah. Yeah.
So you have to find, well, everything that's listed on that app.
Is that? Yeah. Yes. It says I think they when we first was this survey, so she didn't call me. So she went there, so she's up there.
Well, you could, for quantitative, you could just put it in a table. Each flavor and how many, the frequency table, because you have to use the frequency table to graph.
And so we're asking 25 people. But are you asking 25 people? They're out of like the 5, which is like for her that she chose. Okay, yeah.
And you can do a survey online and.
Yeah.
Real.
That's what I was.
Yeah.
And then we make like whatever we worked out, we get there, we put it in a freezer. And then we graph. And then we just answer the questions on like the one slide. Do you want us to put like the graph and the answers on the one side, or do you care if you don't care?
Doesn't matter.
Okay.
Do you mind if I show you? She's still running.
Or for the frequency table, what would I like flavor it?
Yeah.
Places to eat.
Well, for the quantitative, like how is it, how much they're eating out, like.
Oh, you don't, the truth is you don't. Just list all the data and they'll just highlight it all. You only need a frequency table for the qualitative. You don't. Okay, so under projects, there's 2 people that have turned it in so far.
I think.
So after we do the project, we have to do 5 responses to other people's. Are we presenting these?
No,
Oh,
that's why I just had it on a discussion board rather than
I think
taking time to read.
or you could do the same thing.
Okay, so here's one person. To kind of get you an idea, I think it's kind of neat. So she kind of put an entrance one. And then the slideshow, and here's her paragraph about what she found with the pie chart. And then the bar graph. This is from the quantitative data, the histogram. And then she brought in her graphs together to explain what she found. Mean, median, mode, and range, and talked about them. There was a no mode because the numbers were so large, none of them repeated. Scatter plot. It is coming. I didn't even look if I up this one. This was all her data. Or where she found it. Scatter plot, trend line, R squared. And her source. So 9 slides, that was good. Logan, do you mind if I show yours?
No.
So we can turn it in now if you want.
So this one showed the frequency table, which is great. And with the frequency table, you make a bar graph and a histogram. A pie chart, sorry, not a histogram, bar graph and pie chart. How it gathered its data. The quantitative data is numerical. A histogram, because the numbers were so close, it didn't make a great histogram. I put everything into two, but that happens with technology sometimes, and I'm fine with that. Mean, median, mode, and range. So does that help you get an idea of what to look for, the correlation of the data? Here's the scatter plot with the R squared and the equation. Explaining R squared and what changes he would do. Any questions? So as soon as you're done, you can put it up there. And once you put it up there, then you can see other students. I don't think it lets you until you've done, but any questions? That helps seeing others.
So, for mine, I'm doing pick top 5 horror movies and ask 25 people their favorite horror movie. Do I like make a pick the 5 horror movies and ask the people which one is their favorite out of the 5?
Yeah, I think it's a good idea. When you have too many possibilities, then you're gonna get too many answers. Like favorite candy bar, you could get 100 different answers. So then instead narrow it down to the top 5 and have them pick from the 5. So for qualitative, if you're getting too many different answers, just have them pick from 5 or 6, 7, but a smaller amount. You don't want, think of your pie chart if it has 100 little sections in it rather than maybe 5 or 7.
Is 25 people okay, or should I make it 20 or?
You need at least 25.
Okay.
Any other questions? So you should have qualitative data, which is not a number. And then you should have quantitative data, which is a number, an individual number. So you can't use range of values for the second two. They have to be individual numbers. The third one's pairs of data. Question? Looks like you had a question.
Me?
Uh-huh.
Oh, no.
No? Okay. Just the way you looked, it looked. About the what? Oh. You would mean the individual, like how many? It's also giving you the bar graph, right? So I would find different data where it's just giving you the data. Any other questions?
So when it says, in Excel enter data in the first column of the chart sheet. The qualitative data.
And all the data you get, so the qualitative data, another column would be the quantitative data.
This number 2 in Excel enter the data in the second column, so the data in the second column goes with the first one.
So the second column, it doesn't have to go with it.
But I want to separate like the first line, I can list the qualitative, and then the second I can list the quantitative. Okay.
Any other questions?
Yeah. I think I'm gonna take the classes. Do you know when the grades will be in by?
For the project, the project is due on the 26th, so it will be the next day. Although it takes a little bit longer to go through those, so it might take a little.
Yeah.
So the project, you have to post by the 16th and then respond by the 23rd. And so then that following Monday or Tuesday, I should have them graded. If you missed yesterday, the class recording's up here. It's been allowing me to hook up onto WebEx now. So if you can't make it to class, you can always log in. The link is on, the top online classroom link. Yes.
Zoom in. I tried to access yesterday, but
What was your question? Anything?
like I was on the online yesterday and I see everything you're writing on board and trying to get your attention.
On the on here?
Like you saw the whole thing and you can see that you're writing, but it's really hard to tell what. I don't know. So it's like yes, no.
That's weird. So like over here,
Like yeah, you can see that you're writing, but it's hard to
see
tell.
what it is.
I don't know how to change.
You know what else? It probably put you right next to me, didn't it? So then it made it even smaller. It won't let me pin it unless someone else is on and, I don't know. To keep working on it, but yeah, I don't know what to do about it not showing. Yeah, that is. It's even backwards. Don't you just love technology? Don't hear my image. There we go. There's a new stuff on here and I don't know it all. So I'm still learning. Oh. I know I had a student last semester who said she didn't have any trouble, but she had a big screen TV at home and she put it up on the big screen. But. Well, at least now it won't be backwards. All right, chapter 5, we finished the first 2 sections. How much we'll get done today, but that's okay. Was there any other questions on the project? So tomorrow, make sure you bring technology to work on my math lab, at least the second half. And so if you have questions with that or your project, I can come around and help you individually, make sure everything's being entered right on your project and. Okay. Binomial distribution. Binomial distribution is when there's 2 outcomes. Tossing a coin, heads or tails. True or false test. boy, girl. Things that have two outcomes can be a binomial distribution. So for a binomial experiment, it's a probability that has four requirements, and one of them, it has to have only two outcomes. No, some things, does rolling a die have two outcomes? Depends on what the question is, right? Normally, it's 1 through 6. But we could make it binomial by doing even and odd. So some things, even though they may not have only two outcomes, you can make them two outcomes. If you're picking a letter from the alphabet, you could do vowel and consonant. But then you'd have to specify why, but you still could do it. And that's what they mean here, or outcomes that can reduce to two. Then they have to give you a fixed number of trials. They can't say that you're gonna roll a die infinitely number of times. They have to give you a specific, like rolling a die 5 times, how many times do you get even? The outcome of the trials are independent of each other. Each time I roll a die, what I get on that one doesn't change the next probability. So each probability is equally likely. It doesn't change its probability. They're independent. The probability of success remains the same for each trial. Those kind of go together, 3 and 4. I don't know why your book made them separate. I guess because then you can't change your success. So when you're going to use binomial, you want to check these 4 things. So if we look at this first one, draw 10 cards from a standard deck of 52 cards without replacement and record whether a card is a diamond or not. Are there only 2 outcomes? We're recording diamond or not a diamond. That's 2. Is there a fixed number of trials? Drawing 10 times. So there's a fixed number of trials. The outcome of the trials are independent of each other. So if we pull a card and don't replace it and then pull another card, are they independent? No, because the one depends on what the other one is, which means the probability of success is also changing each time. So it would not be. How could we make it binomial? How can we make it independent? Put the card back. And then the probability each time is the same. So the successes doesn't change and it's now independent. So sometimes you can change things. If we replace the card, then this would be binomial. Okay, look at the next one inside. Or look at the next 3. Maybe I can. I'm gonna try and get them all up there. There we go. So try the next 4. Write your answers down and then we'll go over them. So if it's not binomial, make sure you state why and how we could change it. Look at the first one. Well, actually, it's the second one. Rolling an unbiased die 100 times and recording the score from 1 to 6. Is it binomial? No. Why? Which one of the 4 does it fail? Rolling 100 times, so that's B, or number 2. Fixed number of trials. And 3 and 4, it's individual because you're rolling a die, it's unbiased. But our outcome is 1 to 6. You can only have from part 1 2 outcomes. So since there's 6 outcomes, it's not binomial. How could we make it binomial? Yeah. Well, no, because we'd still have others outcomes because we could, so you can't just go 5 or 2. It has to be covering all of the outcomes, all 6 of them. So we could go 5 or not 5.
So I don't know what products that I have it, like these ones are black and these ones are, this is white and gray. And they were really spinning the wheel.
Yeah. Even and odd. Less than 3. Or greater than or equal to 3. Some way so that every time you roll it, there'd be only 2 possibilities. Flipping a fair coin, so 2 possibilities, heads or tails, until heads is thrown 3 successive times. Well, it definitely does the first one because heads or tails. And the last 2 work because flipping a coin is independent and it doesn't change the probability or the number of successes in the next one. But it doesn't tell us how many times to roll it. So the second one, fixed number of trials. If we keep tossing a coin till we get 3 heads in a row, we could be there a while, or we could get them right away. And so that would fail the second one. Drawing 10 cards from our standard deck of 52. So that's our number of trials, 10. We're replacing them, which takes care of the independent because we're putting it back, which means successes are the same. Recording how many times each of the 4 suits, clubs, diamonds, hearts, or spades. Fails the first one, huh? Because there's 4 answers you could get. When you pull that card, you have 4 different possibilities. Well, we could say red and black, then we'd only have 2, face card or a number. But right now they have 4, so that would not work. Recording the number of children in 50 randomly selected families. So if we're selecting them random, they're independent. And successes stays the same. Fixed number, yeah, we're doing 50, so it's fixed. But does the first one have only 2 answers? If you're asking how many children are in a family, you could have 0 to 10 in some cases. So there's not only 2 outcomes. How could we make a question for this that would have 2? Think of yes and no answers. Anytime you can turn something into a yes or no, you've made it binomial. Are there children in the family? Or do you have children? Then you're getting yes or no, whether they do or don't. You don't know how many, so that's a little different. But for binomial, it has to be just 2 answers. Any questions on that? binomial distribution, the outcomes of a binomial experiment and the corresponding probabilities of these. P of S, they usually use a lowercase p for the probability of success. P of F, they use a lowercase q for the probability of a failure. And Q is 1 minus P. Usually you're given the probability of success. And then Q is 1 minus that. Because remember, your probability has to add up to 1. And if there's only 2 outcomes, then P plus Q equals 1. And this is the same as P, which is the probability of success. This is the probability of failure. N is the number of trials. X is the number of successes in N trials. This part's important. X has to be between 0 and N. So if you're tossing a coin 50 times, you can't look for 51 successes. It has to be between 0 and 50, inclusive. So notice this is including 0 and N. And this is the formula. This part, you remember the formula for combination? N factorial over N minus X factorial times X factorial. That's a combination. So if your calculator does combinations, you can use the combination. If it doesn't, you would be using this. But almost all of them do. Does anyone need a calculator? Or have a calculator? Okay. A coin is tossed 3 times. Find the probability of getting exactly 2 heads. Now, we worked this problem out already, but you can also do it in binomial. So we're going to use this example first. So think of the outcome. How many are there? If we toss a coin 8 times, how many outcomes? Or sorry, we gave 8. If we're tossing 2 coins, toss a coin 3 times. Each has 2 outcomes, heads or tails. So there's 8 of them. Okay. These are all the possible outcomes, and this is how we were doing probability earlier. We would list all of them, and they said the probability exactly 2 heads. There's 3 of them. Out of the 8. So from probability we learned before, if you can list your whole sample space, then you can figure the probability out. But if we're doing 100 times or more, doesn't always work. Or if they're giving you a probability. So if we use the binomial distribution, I'll check the variable first. X is 2. N is the number of times we're doing 3. So we're finding if we toss it 3 times, that's why N is 3. And we want to get 2 heads. The probability of a success or the probability of a heads is 1/2. The probability of failure is 1 minus. Well, depending on which one of the 2 formulas, I'll write them both. If we use the first one, n factorial n minus x factorial times x factorial. And then p, 1/2 to the x, which was 2. Q, 1/2 to the 3 minus 2. These 2 should add to n. So I'm just plugging into here. 3 factorial, 3 minus 2 factorial, 2 factorial. P was 1/2, x was 2, so 1/2 squared. Q was 1/2, and then 3 minus 2, which is 1. These 2 exponents add up to n. Or you can do it this way. So if we solve it this way, the 2 factorials will cancel and leave 3 over 1 factorial is 1. Wait, I did something. Oh, I forgot the rest of it. So this would leave 3 over 1. This is 1/4 because 1/2 times 1/2 is 1/4. 1/2 to the first is 1/2, which gives us 3 over 8. You do need to be able to get back to the fraction, not the decimal. But plug it into your calculator, make sure you're getting the right answer. Also practice it with the combination. When you plug this in, you should get 3. But plug them into your calculator. You need to find out if you're entering things wrong now and not when you're doing ALEKS or taking an exam. Is everyone getting 3/8? I mean, this one's an easy one. This is easier to do this way. But not everything can be done this way. Any questions? Let's try number 2. A survey found that 1 out of 5 Americans say he or she visited a doctor in any given month. If 10 people are selected at random, find the probability that exactly 3 will have visited a doctor last month. So think about, is it binomial? Yes or no? Yes or no question. So it's binomial. Whether they visited or not. 10 people, so that would be our N. And we want exactly 3 successes. If 1 out of 5 have been to the doctor, what's the probability that when you choose one, they went to the doctor? 1/5. They're giving you the probability. So the probability of a success is 1/5. What is the probability of failure? Okay, what did you say?
That.
What did you say?
I was just saying it out.
Oh, okay, 1 minus,
Yeah.
okay. When it is not a repeating decimal, you can use the decimal. Is that 0.2? And this would be 0.8, and that's fine. Alice may say answer in fraction form. But if it's a repeating decimal, I want the fraction. So we can do a combination, 10, choose 3, and then success 1/5, and we want 3 of them. 4/5. 10. So we're doing it 10 times. We're picking 10. We want 3 successes. The probability of a success, 1 in 5, and we want 3 of them. Failure, 10 minus 3, this is 7. 7 and 3 gives you your total 10. So 3 successes, 7 failures. Go ahead and plug it into your calculator. And you can write the decimal. I don't know if it turns to a fraction. If you have an 83 or 84, the probability is under math. And then go over to the right to probability. And then it has your permutation, your combination, your factorial. This calculator has probability right here. When you click on it, then it has across the top permutation, combination, factorial, whichever one you want.
Can you go over this for the test?
Yes.
Thank you. I mean, not like obviously not as much for the test, but
Yeah. I will always review the, I put the exam on final on Friday, so we will review Monday, Tuesday, Wednesday, just like the last one.
Would it answer this?
So you go, I think you put the 10 first, and then you would go to or combination. I've never tried it on this. Yeah, you put the 10 first, and then you go to the symbol, and then you put the 3 and hit enter. You should get 120,
Yeah.
and then you multiply these things. Is everyone getting 0.201?
Negative.
We don't have any negative numbers.
You have to move the thing over.
That dash for.
You went 10 minus 3. You would have to take to the 10 and then subtract it from the answer.
That's why I was confused. It's like, I also got
Either
it.
get the 7 first or put the 10 minus 3.
Good to put. Savage hit, am I?
No, but fine. I think you could bring that up again.
Sorry.
When you have something that's tight, probably that's something together, it'll bring it back up.
It's the.
They're the same, either one.
This thing goes down.
It's just, if you're at home and hopefully it doesn't.
Chick-fil-A or what?
Yeah. Either one's fine.
I ate Chinese last night at the Diamond Mall and some of them minutes. If you are Chinese, then you won't do they have special like segments. Yeah. So it's like and you get to
No, but like you could do it.
and it'll last you like that's not for your week. It'll last you. So. I'm sick of Chick-fil-A, so I wouldn't.
Was, well, I watched your video yesterday on that online thing. And what we learned yesterday was like with the variance and the, like, standard deviations back in class or was you take out?
I'm not sure.
Okay,
I'm not sure yet, because I haven't made
Well,
it.
you're not gonna make it from.
I'm fine with the, what were those?
Maybe
names?
it's
The
Oh, well. Well, when
Oh, the distribution.
table, yeah, those, yeah, those
are easy.
yeah, those are easy. Even the,
yeah.
variance, the standard deviations, they're fine, just finding. Equation. But,
Yeah.
okay.
Yeah, square,
Like,
yeah. I probably wouldn't put them, I'd probably just put them in there.
Okay, I'm gonna, start my project tonight, so can you check it tomorrow?
Mhm.
Like just some of it, okay?
Yep.
Okay, see you tomorrow.
You're still not tired of us yet?
No, I'm starting to enjoy this class. I haven't taught stats in a classroom probably in maybe 8 years. I've taught it online, like through Easter Gateway. But it's been a long.
I don't know how you do it, because that's just, wow, you can. Definitely not high school, but it's not that it's hard. It's more of the equations that kill me.